Hi friends, so we meet again and we shall start our discussion where we left in the previous lecture. In the previous lecture, we discussed the use of digital video in multimedia, analog and digital technologies, and also talked that motion video is the element of multimedia that firmly holds a student's interest in a computer based learning project. Digital video is the most engaging of multimedia venues, and it is a powerful tool for bringing computer users closer to the real world. It is also an excellent method for delivering multimedia to television audience. With video elements in your project, you can effectively present your messages and reinforce your story, and viewers tend to retain more of what they see. Today we shall be talking about digital video containers, codec, video formats, and finally the procedures to shoot and edit videos. Digital video containers. A digital video architecture is made up of an algorithm for compressing and encoding video, a container in which to put the compressed data, and a player that can recognize and play back those files. Common containers for video are Flash Video, MPEG, QuickTime, Windows Media Format, and Real Media. Containers may include data compressed by a choice of codecs, and media players may recognize and play back more than one video file container format. Container formats may also include metadata, that is, the important information about the tracks contained in them, and even additional media besides audio and video. The QuickTime container, for example, allows inclusion of text tracks, chapter markers, and transitions. LiveStage Pro is an authoring tool that can produce interactive multimedia self-contained within a single QuickTime container. Codecs. To digitize and store a 10-second clip of full motion video in your computer requires the transfer of an enormous amount of data in a very short amount of time. Reproducing just one frame of digital component video at 24 bits requires almost 1 MB of computer data. 25 seconds of full screen uncompressed video will fill a gigabyte hard disk. Full size, full motion uncompressed video requires that the computer delivers data at about 35 MB per second. This overwhelming technological bottleneck is overcome using digital video compression schemes or codecs. A codec is the algorithm used to compress a video for delivery and then decode it in real time for fast playback. Different codecs are optimized for different methods of delivery. Codecs such as Theora and H.264 compress digital video information at rates that range from 50:1 to 200:1. Some codecs store only the image data that changes from frame to frame instead of the data that makes up each and every individual frame. Other codecs use computation intensive methods to predict what pixels will change from frame to frame and store the predictions to be deconstructed during playback. These are all lossy codecs where image quality is sacrificed to significantly reduce file size. MPEG. The MPEG standards were developed by the Moving Pictures Expert Group, a working group convened by the International Organization for Standardization and the International Electrotechnical Commission, which created standards for the digital representation of moving pictures as well as the associated audio and other data. Using MPEG-1, you could deliver 1.2 Mbps of video and 250 kbps of 2-channel stereo audio using CD-ROM technology. MPEG-2, a completely different system from MPEG-1, required higher data rates, but also delivered higher image resolution, improved picture quality, interlaced video formats, multi-resolution scalability, and multi-channel audio features. MPEG-2 became the video compression standard required for digital television and for making DVDs. With MPEG-4, multiple views, layers, and multiple soundtracks of a scene, as well as stereoscopic and 3D views are available, which make virtual reality workable. MPEG-4 can adjust to varied download speeds, making it an attractive option for delivery of video on the web. The MPEG-4 AVC requires the H.264 codec for Blu-ray discs. Because the software behind MPEG-4 is patented by more than 24 companies, developers who build video editors and players that read and write MPEG-4 files must purchase licenses and make royalty payments. Video format converters. Be prepared to produce more than one version of your video to ensure that the video will play on all the devices and in all the browsers necessary for your project's distribution. DVD video uses MPEG-2 compression, Blu-ray video uses MPEG-4 compression. To save in these known standards, simply click Save for DVD or Save for Blu-ray. But if you need to prepare a video file that will run on an iPod, an Atom-based netbook, as well as in all web browsers, you will need to convert your material into multiple formats. There are many free, shareware and inexpensive file format converters available for multiple platforms. Figure shows a menu of video format selections and profiles available in the free converter Handbrake for Mac and Windows. After you have decided that your project should and will include video, consider whether you should shoot new footage or acquire pre-existing content for your video clips. There are many sources for film and video clips. A friend's home movies may suffice, or you can go to a stock footage house or a television station or movie studio. But acquiring footage that you do not own outright can be a nightmare. It is expensive and licensing rights and permission may be difficult, if not impossible to obtain. If your budget can't cover the cost of licensing a particular video clip, you may want to consider using other alternatives. You could try locating a less expensive archival video source using a series of still images rather than video, or shooting your own video. If you shoot your own video for a project, make sure you have talent releases for all persons who appear or speak, and also obtain permission to use the audio effects and music you weave into it. For projects that are focused on training, particularly training people to use software applications, video screen capture of mouse and key activity is widely used, along with a voiceover soundtrack. Video screen capture tools for both PC and Macintosh systems will generate video files that can then be edited and integrated with audio. One e-learning and courseware authoring program, Adobe's Captivate, will not only capture your own screen activity, but also allow you to import video in a wide variety of formats and edit it in your final project. Shooting and editing video. Before you head out to the field with your camcorder in hand, it is important to understand at least the basics of video recording and editing, as well as the constraints of using video in a multimedia project. Setting up a production environment for making digital video requires hardware that meets minimum specifications for processing speed, data transfer, and storage. Depending on the capabilities of your camcorder, there are many considerations to keep in mind when setting up your production environment. Expensive professional video equipment and services may not yield proportionately greater benefits than if you used consumer grade equipment and nonlinear editors. As with audio equipment, you need to make balancing decisions. Most likely, your goal is to expend resources without diminishing returns, or in other words, produce multimedia that is adequate and does its job, but doesn't break your bank. If you can, experiment with various combinations of video recording and playback devices hooked to your computer and test the results using your multimedia authoring platform. You can do a great deal of satisfactory work with consumer grade video cameras and recording equipment if you understand the limitations of the technology. The shooting platform. Never underestimate the value of a steady shooting platform. A classic symbol of amateur home movie is shaky camera work. Using a tripod or even placing the camera on a stable platform such as a rolled up sweater on the hood of a car can improve a shot. With a little care and careful adjustment of the lockdown screws and sturdy conventional tripod can do wonders. If you must shoot handheld, try to use a camera with an electronic image stabilization feature for static shots, or use a Steadicam balancing attachment. Even using a rolling office chair and sitting facing the back with the camera balanced on the chair back makes a convenient stable dolly. If you must shoot handheld, set the camera's lens to the widest angle. At wide angle, camera motion becomes smaller relative to the field of view and is thus less apparent, and invest in an external microphone like a lavalier. It will give you better audio than the on-camera microphone during interviews, and you can easily hide it in the scene during general use. Storyboarding. Pre-planning a video project is a factor that cannot be ignored without costing time loss, lots of unnecessary aggravation, and money that would be better spent elsewhere. Successful video production of any sort deserves the time it takes to make a plan to carry it out. It may take a little time at first, but you will find it to be very helpful in the long run. Storyboards are like any sequential comic you read daily. Every day there are 3 or 4 panels showing a progression of story or information. Take the time to structure your production by writing it down and then engineer a sequential group of drawings showing camera and scene, shooting angles, lighting, action, special effects, and how objects move through from start to finish. A storyboard can get everyone on the page quickly. Lighting. Perhaps the greatest difference between professional camcorders and consumer camcorders is their ability to perform at low light levels. With proper lighting, however, it may be difficult for viewers to differentiate between shots taken with an expensive studio grade video camera and an inexpensive camcorder. Onboard battery lights for camcorders can be useful, but only if in conditions where the light acts as a fill light to illuminate the details of a subject's face. As in photography, good lighting techniques separate amateurs from professionals in video shoots. The standard lighting arrangement of a studio is as shown here, with fill, key, rim and background lights. Changing any of these lights can make a dramatic difference in the shoot. Part of the pre-production process involves carefully thinking through your lighting design. In positioning lights in a studio, considerable time is involved in climbing ladders and hanging and connecting lights. To reduce the problems, especially in complex settings, you need to plan out the whole effect with a paper and pencil or a computer drawing program before you start. If you are lucky enough to be able to get someone else to actually hang the lights for you, you will still need to have a way of indicating where you want each one placed. But even if you must hang the lights yourself, having it all planned out on paper will save you time and trouble. Chroma keys. Chroma keys allow you to choose a color or range of colors that become transparent, allowing the video image to be seen through the computer image. This is the technology used by a newscast weather person who is shot against a green background that is made invisible when merged with the electronically generated image of the weather map. The weatherman controls the computer part of the display with a small handheld controller. A useful tool easily implemented in most digital video editing applications is green screen, blue screen or chroma key editing. Green screen is a popular technique for making multimedia titles because expensive sets are not required. Incredible backgrounds can be generated using 3D modeling and graphic software. One or more actors, vehicles or other objects can be neatly layered into the background. Video editing applications provide the tools for this. When you are shooting green screen, be sure that the lighting of the screen is absolutely even. Fluctuations in intensity will make this key appear choppy or broken. Shooting in daylight and letting the sun illuminate the screen will mitigate this problem. Also be careful about color spill. If your actors stand too close to the screen, the colored light reflecting off the screen will spill onto them and parts of their body will key out. While adjustments in most applications can compensate for this, the adjustments are limited. Beware of fine detail such as hair or smoke that does not key well. Composition. The general rules for shooting quality video for broadcast use also apply to multimedia. When shooting video for playback in a small window, it is best to avoid wide panoramic shots as the sweeping majesty will be lost. Use close-ups and medium shots, head and shoulders or even tighter. Depending upon the compression algorithm used, consider also the amount of motion in the shot. The more a scene changes from frame to frame, the more delta information needs to be transferred from the computer's memory to the screen. Keep the camera still instead of panning and zooming. Let the subject add the motion to your shot such as walking, turning, talking. Beware of excessive backlighting. Shooting with a window or a bright sky in the background is a common error in amateur video production. Many cameras can be set to automatically compensate for backlighting. If you adjust for this, the background may be blown out, but at least the foreground image you are focusing on will be visible. But of course, the best choice in this situation is to light the foreground. Non-professional cameras are set to always adjust the iris to keep the image's overall exposure at a constant level. When you go from a dark to light setting, the camera will adjust and you can often see this shift. Pro cameras allow the iris setting to be locked down to avoid this. In different situations, white may not be white depending on the color temperature of the light source. White balance corrects for bluish, orange or greenish color casts resulting from an uneven distribution of colors in the spectrum. Many cameras automatically set white balance with best guesses, but they also offer adjustable settings for daylight, shady, cloudy, tungsten and fluorescent light conditions. Nonlinear editing. Top of the line nonlinear editing software includes Adobe's Premiere, Apple's Final Cut and Avid's Media Composer, the A-team of professional video editors. These are feature packed and expensive packages designed to work hand in hand with fast and powerful computers and dedicated file servers. Many hours of training and many days of experience are needed before users become proficient. If your project involves simple cutting and editing of footage with a few transitions and titles thrown in, then you may be satisfied with simpler software such as Microsoft's Windows Movie Maker or Apple's iMovie for Macs that comes free with the operating system. Table here contains a list of free video editing software applications to choose from. Remember not to edit and re-edit. The video codecs used are lossy, so each time you finalize a file, it will be less true than the original material. This is called generation loss. Because NLE software works with EDLs based upon the raw source video, be sure you have sufficient disk space to store your original footage. Today's nonlinear computer editors are capable of just about any effect you can dream up. Because of this, it's tempting to try to impress your audience with all the production razzle dazzle you can manage. But whenever any production technique calls attention to itself, especially in dramatic productions, you have diverted attention away from your central message. Video professionals, or maybe we should say true artisans of the craft, know that production techniques are best when they are transparent, that is, when they go unnoticed by the average viewer. However, in music videos, commercials, and program introductions, we are in an era where production, primarily editing techniques, are being used as eye candy to mesmerize audiences. The video editing system shown, for example, is capable of creating about any type of effect. So, this brings us to the end of our discussion about videos, and therefore, we summarize. In this lecture, we have learned to work with digital video containers and codecs to select the best video recording formats for multimedia projects. We have also learned the art of shooting videos if we are not able to purchase them with best of lighting and with proper color temperature. And lastly, we discussed the various NLE machines to be used. So, that's it folks about videos. See you in the next lecture. Thank you very much.